What happens to a material when it transforms from three dimension to two dimension? What changes occur in a material when it goes from three dimension structure to two dimension structure? There are three major changes occur. The first one is removal of van der Waals forces. The second one is there is a significant increase in surface area. Significant increase. The last one is there is quantum confinement. This means that when the size is getting lower than 100 nanometer, there is quantum confinement effect. There is a tremendous changes in the optical and electronic property of material. Right? This is three-dimensional material. This is we also call bulk material. The best example is basically graphite. The best example is graphite. Graphite is a three-dimensional material, right? Look here, this graphite is basically made from sheets. So a single sheet, which is called two-dimensional, this is basically called graphene, right? When we remove this one layer from three-dimensional using etching method, mechanical exfoliation, any method, so this is basically called two-dimensional. Now, if you look into this sheet, there are atoms, right? So there is basically covalent bond inside this sheet between the atoms. But this sheet attached with this sheet through van der Waals forces, right? So this means that when we get two-dimensional material, so there is removal of van der Waals interactions because in a single sheet, atoms are bonded through covalent bond, and this sheet is bonded or make bond with this sheet through van der Waals forces. And van der Waals forces are weak forces, and covalent forces bonds are strong forces. This is why we easily remove this sheet from three-dimensional structure and we get two-dimensional structure. In this two-dimensional structure now, there is no van der Waals forces, only covalent forces exist between the atoms here. And we know that covalent forces are strong forces, but van der Waals forces are weak forces. This is why two-dimensional material is stronger than three-dimensional material, right? The second one is increase in surface to volume ratio. This means that the surface area, this is we sometimes called the specific surface area. The specific surface area. It has a units meter square per gram. This means that this is three-dimensional material. Let's suppose here, this is a block here. It has some surface area. Now, when we divide this into four parts, something like this, 1, 2, this is third part, this is fourth part. Now, this material now has increased surface area because we have more exposed surfaces, edges here. You see here, but here we have only these edges. So there is a significant increase in surface area and there will be more reaction. The best example is if you have sugar, a big pieces, and if we have sugar of small pieces, so in which case the sugar will dissolve faster in the small cases, because in small sugar it has more surfaces, so it will make more reaction, it will dissolve faster, right? The last one is a confinement of electron in a plane. As we already know that this is three-dimensional material, none of dimension is less than 100 nanometer. But if you look into the two-dimensional material, two-dimensional, so this is the length, this is the width. It is above 100 nanometer, but if you look into the thickness, so the thickness is less than 100 nanometer. This means that this is we call two-dimensional nanomaterial. So there will be a quantum confinement effect. And we know that when we decrease the size, there is a significant changes in optical property and electronic properties. How optical property? Because when we decrease the size, so the band gap basically increasing. The band gap basically increasing when we decrease the size. So when the band gap increases, so it will absorb some different lights, and also it affects the conductivity, right? This is why it says that when a material transforms from 3D to 2D, it means less material. We use less material, correct? thereby increases Coulombic interactions. When we increase Coulombic, so is a result of more strongly bonded excitons, correct, in making the material more stable. This means that 2D material is more stable than 3D material. Thanks for watching.